Hi guys, I am Debo Hosello. I am a biology and chemistry teacher. So today I would like us to do some chemistry together. I would like us to deal with the concept of electrolysis. But then first of all, let's talk about what is electrolysis. Scientists say that electrolysis is whereby compounds are being decomposed using electricity. So this means electrolysis is electricity in chemistry. So as you did in bonding, whereby you know that there are ionic compounds. In bonding you were taught that ionic compounds, when they are molten or when they are dissolved in water, they conduct electricity. So now let us see how does electrolysis work. Electrolysis happens in an electrolytic cell. In electricity, there are always the positive and the negative terminals. So now, we are going to have our electrolytic cell. This is how it is going to work. I have my electrolytic cell here, and I have the terminals. I have the positive terminal, and then I'm going to have the negative terminal. So now here I have drawn what are the batteries or the cells. The battery is the one that is going to pump up electrons to our electrolytic cell. So here we are going to have our electrodes. We have our two electrodes. After the electrodes, we have to have what we call an electrolyte. Our electrolyte is that substance that is going to contain our electrolyte. So the electrolyte is the one that has the charges. So here we have our electrodes. These are the electrodes. We have our electrodes. And then this one, the positive electrode, normally they call it an anode. This one that is the positive one is called an anode. And our negative terminal here is called the cathode. So the battery is going to pump the electrons. Normally the electrons are going to move from a positive terminal to the negative terminal. So now this is our electrolyte here. We have our electrolyte that has the positive and the negative charges. So during electrolysis, the positive charges are going to be attracted towards the negative electrode, because in electricity, like charges, they always repel. So this means this is the anode. When the electrolyte is being decomposed, the positive terminal is going to attract the negative charges. And here on the cathode, which is our negative terminal, is going to attract the positive charges. So inside the electrolyte, inside our electrolyte is whereby our chemical reactions are going to take place. So when chemical reaction takes place, we talk about oxidation and reduction. So here at the anode is whereby oxidation is going to take place. Oxidation is going to take place on the anode. And on the cathode here, reduction is going to take place. So now this means electrons here are going to be given up on the other side, and on the other side electrons are going to be received. So now this means that the anode is going to take oxidation, and here at the cathode is whereby reduction is going to take place. So all this thing now is what you call an electrolytic cell. So now we are going to do a simple electrolysis of a molten sodium chloride. We are going to do an electrolysis of a molten sodium chloride. molten sodium chloride. So now, this is our sodium chloride. Is now going to be dissolved inside the, dissolved in the electrolyte here. So now, these electrodes, normally they are made up of carbon or graphite. They conduct electricity, but they are the less reactive metals. So this means these electrodes, they are not going to react with our products of electrolysis. So now, there we come, sodium chloride. Immediately, when sodium chloride is being dissolved inside our electrolytic cell, we are going to have the sodium ions and we are going to have the chlorine ions. We are going to have the sodium ions and the chlorine ions inside in our electrolyte here. So this is what is going to happen. The cathode, which is the negative terminal, is going to attract the positive ions, which means sodium ions are going to be attracted to the negative terminal. And the negative ions, which are the chloride ions, are going to be attracted towards the anode. And then we are going to have some chemical reactions that are going to take place at the anode and the one that is going to take place at the cathode. So this means sodium, the one that is going to go to the cathode, we are going to see the first reaction that is going to take place at the cathode. We are going to see sodium ions going to the negative terminal, whereby this reaction is now going to take place. And on the other hand here, we are going to see chlorine or the chloride ions, which are the negative ones, coming onto the anode. And then we are going to have chlorine. It is now going to come to the anode, and then we are going to have the ions here. We are going to have two chlorine, the chloride. So if here there are two, it means here they also have to be two of them. So this is the anode reaction, and then here is going to be the cathode reaction. And then we are going to have an overall reaction, whereby it's going to show that a sodium chloride have been electrolyzed. This is a electrolysis. It is going to be electrolyzed to give sodium and our chlorine. So now, balancing the equation is always very important. Here, the equation is not balanced. Here we have two chlorine atoms. Here we have got one. So it means we have to balance. When we balance them, we also make sure that on the product side and on the reactant side, the numbers are equal. So now we have two sodium, and then we have two chlorines. Here we have two chlorines, here we have only one sodium. So it means we have got to put another two here. Now our overall reaction is now balanced. This one is the overall. Here is the anode reaction, here is the cathode reaction. So now I would like you to do a simplest one. So this one is the electrolysis of molten sodium chloride. So at home, you can do a little bit practical. You can do electrolysis of molten lead bromide. Show how to electrolyze a lead bromide in an electrolytic cell. Okay, so now this is the exercise I have just mentioned. Electrolysis of lead 2 bromide. So you show normally you don't have to draw the whole thing again. All we can do now is to show the cathode reaction and the anode reaction. Then you do the overall reaction. That will be all. Thank you.